What is a city, and how do we use our knowledge about cities to support the move to water sustainability in a world where cities are growing and the climate is changing? Environmental engineers have had their own response to the ways in which we should think about cities since the pioneering work in the mid-1960s of Abel Wallman, who coined the term urban metabolism to study the way in which resources moved within cities and the ways in which cities could be adjusted to make them more efficient with respect to water resource uses. In contrast, architects and historians have had a different view of cities and the way in which they relate to water and resources. In particular, they've seen cities as entities that grow with time as the culture around it changes and the people living within the city have different ways in which they want to realize transportation and water use and access to technologies. Today, we're going to have two speakers who bring together those views of the ways in which cities function, the ways in which they interact with water, and the ways they'll have to change in the future to make water more sustainable. Our first speaker comes from the School of Environmental Engineers, and it's Steve Kenway from the University of Queensland, who's going to give us a talk titled Designing Urban Water Systems. Steve is a research group leader at the University of Queensland, where he's been active in water research issues related to urban metabolism since about 1990, working with various utilities and government agencies, as well as academics within the University of Queensland. Uniquely, he approaches cities as three-dimensional entities and thinks about the way in which urban design and new approaches for water technology come together and affect the problem of establishing a sustainable urban metabolism. Our second speaker in the water webinar series today comes from the standpoint of an architect and historian. Pieter Uyttenhove of the University of Ghent is going to talk to us about living with water. Pieter is a professor at Ghent University in the Department of Architecture and Urban Planning, where he's been since 2010. His research interests are related to urbanism, landscape, history and theory of urbanism, and landscape history. In the spring semester of 2020, Pieter held the Peter Paul Rubens Chair at the University of California, Berkeley, where he participated in the College of Environmental Design and gave seminars on the history of urbanism, cities, and in particular, the water landscape of Flanders. And so with that in mind, we're going to see these two different views of water metabolism in cities and hopefully emerge with a new approach and new appreciation of urban metabolism and urbanism in our cities.
Good afternoon. My name's Stephen Kenway. I'm at the University of Queensland, where I'm a research group leader for water, energy and carbon. As a part of the Water and Architecture series, I'd like to talk with you about designing and assessing water-sensitive systems, precincts and cities, and I'll have a particular focus on concepts, tools and applications. In summary, I'd like to talk about water, city development and growth, and what is the problem of water in cities as they're growing. I'd like to talk a little about the urban metabolism concept and its use for analysing performance of cities and how they're managing water holistically. I'd like to talk a little about tools guided by the metabolism framework and its application for designing water-sensitive cities and precincts. I'd like to briefly mention design challenges and give some references if you're interested in these concepts further. So what is the problem of water in cities? And I particularly look here at the issue of infill development in cities. Infill in cities is expected to be significant as cities grow and they're constrained on their outer edges by other land uses. In many Australian cities, about 90% of the expected development is infill, more intense use within existing allotments and going higher, etc. And what that's meaning is increasingly large areas of impervious surface, roof area, road area, driveway area, and less green space, less and less opportunity for water to get into the soil. That makes more runoff, more stormwater runoff, which leads to downstream flooding. And it makes our cities hotter because there's less shade, meaning a need for more air conditioning and energy. And some of the problems we have with this is we don't have in our current urban design and assessment we do not have adequate performance bases to assess these designs and developments. We also have limited new design options and inadequate current governance arrangements to really manage this problem, which is continuing to grow. So there are a range of key questions related to this problem. How can we actually quantify the performance of these cities or subsystems within cities? How do we define that? How do we measure it? And how do we assess it? For example, across water, energy, and nutrients. What is the impact on hydrology, heat, and livability of new design options? How can best or optimal solutions be found? And how much do we actually change cities if we're changing things little bit by little bit? There's a related question. So what information is critical to solutions? What technologies suit different typologies or types of households and scale? And how does governance or policy or management approaches work or fail? And how can greater success be achieved? I'd like to talk a little bit about the concept of urban metabolism and how it's relevant here. So a hero in this space is Abel Wallman, who over 50 years ago published a fantastic article in Scientific American about the metabolism of the cities. He published that as a concept to simultaneously deal with shortages of water, pollution of water and air, largely because a lot of energy generation was back within cities and it led to smog and particulate matter, and related public economic decisions. So he presented as three-dimensional flows of matter through cities, the quantities of water, food, fuel moving into cities, and the quantities of sewage and refuse moving out. And he really showed just how dominating water is as a flow of material through cities. And in looking at this in great detail in American cities, he concluded there is no shortage of water. However, there is a need for long-term thinking. That work on metabolism has spawned a whole series of research over the following 50 years. Our application of it is to use particularly the mass balance, the quantification of material flows through cities. And we use that to quantitatively analyse and demonstrate how wasteful and poorly designed our cities currently are. So this is an example of Melbourne, which is actually a world-leading water-sensitive city back in the time of the Millennium Drought when it was famously running out of water. Back at that time, around 2010, centralised water supplies are around 365 gigalitres or 365 billion litres of water were coming in from piped water outside the city. And from that, nearly 300 or 297 gigalitres of wastewater was flowing as waste. The rain falling just on that urban footprint each year was some 1,400 gigalitres, and some 1,200 gigalitres were evaporating from the city. It was only reusing around 31 gigalitres of wastewater, so well less than 10% of its demand. So we used our performance indicators, which you can see down the bottom, to demonstrate that if Melbourne could be designed to capture and reuse all its wastewater and all its stormwater, it could meet a very large percentage, 81% and 127% respectively. Obviously, there's design and infrastructure challenges, but conceptually, it's a very large number, a very large proportion of Melbourne's water supply could be from within. Rainfall alone could comprise or could supply, if it could all be caught, and obviously some rainfall needs to flow to natural waterways and streams to enable them to keep living and thriving. But conceptually, it could provide nearly 400% or fourfold the total water currently demanded by Melbourne at that time. So you can see from these mass balance numbers just how wasteful our cities are currently designed with regard to providing water from within or acting as water supply catchments in their own right. Before I go further, I'd like to talk a little bit about language, about urban metabolism, urban water metabolism, and water mass balance. So at its broadest, urban metabolism is about all flows of water, materials, and energy through cities. If we look at a subset of that and look at urban water metabolism, so before we move forward, I'd like to articulate some language, the language of urban metabolism, urban water metabolism, and water mass balance. So at its broadest, urban metabolism covers the mass balance or flow of materials, all materials, water and energy through cities. Urban water metabolism focuses on all water flows and the related influence on energy and materials. And some of those related influences are interconnections outside cities or within cities. We hear the term the water energy nexus. So some energy is influenced by water and some water is influenced by energy. If we look at water mass balance, we are only focusing on H2O molecules and how they flow through cities. And over on the right-hand side, you can see the letters C, B, and B, which is performance assessment. So how do we quantify the performance? How do we put ratings on how well designed cities are? Metabolism and mass balance is a fantastic way for doing that. Moving forward, we transform cities and measure their improvement. So the current paradigm is the top left, where we have energy, water, and materials flowing through cities, but relatively misaligned performance indicators of ecosystem health, human well-being, energy, water, materials, and waste. They're commonly assessed for cities, but not necessarily to a consistent system boundary. So there's currently fragmented analysis, no common system boundary, the effects of interactions we're often not considering, and consequently there's trading of impacts. In future, we'd see much more coordinated analysis to a common system boundary and starting to factor in and take account of those interactions like the water, energy, food nexus in much more detailed quantification. The main project I'd like to talk about now is a project with the CRC Water Sensitive Cities, which was created by the Commonwealth Government between 2012 and 2021. And water sensitive cities are seen as more sustainable, livable and resilient, very similar to blue cities or sponge cities or other similar concepts internationally. The particular CRC has over 80 partners in Australia, and we've been fortunate to work on 2 major projects with the CRC Water Sensitive Cities. So in essence, a water sensitive city helps provide water security for economic prosperity through efficient use and diverse available resources. So it's really maximising the functionality of water. It enhances and protects the health of waterways and wetlands, the river basins that surround them, and the coasts and bays. It mitigates flood risk and damage and creates public spaces that collect clean water and help recycle water. So there's some examples of water sensitive elements within cities being built in my hometown here in Brisbane, in Coorparoo. As I'm talking about models, I briefly wanted to talk about models that are used to quantify performance, because that's the focus here. If we can quantify the performance of cities, we can design them better. So this is some work recently published by our PhD student Mojtaba Moravec, where he's reviewed all urban drainage models, urban water mass balance models, and integrated water systems models. And he has looked at particularly tools that cover all of those flows in a mass balance sense. So all the water cycle flows, including P, which is rainfall, ET, evapotranspiration, stormwater, recycling, centralized water supply, and wastewater. But then also mitigation opportunities, the technologies of rainwater harvesting, stormwater harvesting, wastewater reuse, etc., including green roofs. Then also can drive performance indicators at different spatial scales from site to precinct to city. And he has looked at the suitable method to really evaluate the design of cities. These grey boxes at the bottom covers all water cycles, all the mitigation opportunities, and particularly relevant at site scale, because so much design and development is occurring at site scale, and then that applies upwards to precinct scale. And mass balance is so helpful here because it helps unpack a 3-dimensional entity, which is the design, and that entity interacts with all flows of water. And understanding the mass balance is really essential for water performance. It's very different to doing a mass balance of a 2-dimensional space. A mass balance needs to look at all inflows to, all outflows from, or all water stored within that particular entity. It's very different to other approaches that will do a mass balance for a pipe. You can do a mass balance for a pipe by saying all the flows into the pipe equal to all the flows out of the pipe. And water utilities do that regularly to make sure they're not losing water. Or they do it for more complex systems like networks or catchments or storages. But doing it for a 3-dimensional entity which involves a building or a set of buildings, a landscape with drainage and soil and vegetation, and infrastructure elements like rainwater tanks or pipes, etc., and human behaviour becomes much more complicated. An evaluation framework that we have created to assess the performance of cities has been recently published by the CRC Water Sensitive Cities, available on the link. And essentially, the way we evaluate the performance of cities is to define the area and the infill scenarios. So we'll be talking a lot about the existing state, the business as usual state, and the alternative infill state. The next step is the definition of the parameters. So are we interested in environmental parameters, built form, urban design, or water servicing? So once we have the information and data for those parameters, we undertake an urban water performance analysis, an architectural and urban space analysis, and an urban heat analysis. I'll mostly be talking about the water performance. Our colleagues in architecture and microclimate do the architectural and urban heat analysis, but they are highly interrelated with the water performance. And we represent these on these radar graphs, which I'll also describe in this presentation. In brief, the infill performance evaluation framework works through design parameters. So typically planners and architects work with things like roof surfaces or car parking or paved or vegetated surfaces. They look at midpoint. We then can use that to derive midpoint indicators of hydrology or water storage or water resources management or heat, etc. And then we can look at endpoint indicators, which might be infiltration coefficients or evapotranspiration coefficients using different quantified models. But the consumers, the people who live in these households, are more focused on the right-hand side. They're interested in what's the outcome for them around livability or water or heat or amenity. They're interested in will it flood? Are there green spaces for children to play? How resilient will it be for drought? How hot is it? And is it a nice place to live in? So that's also published on the CRC website with a link at the bottom there. So we bring together water mass balance to assess existing, which is the left-hand case, the business as usual, and design. And we put a three-dimensional boundary, this three-dimensional box around those cities going down to about 1 metre deep, to really characterise what is the influence of the city, the design, and how is that impacting flows of water demand, precipitation, evapotranspiration, stormwater runoff, wastewater, and infiltration. The framework has core principles, which I'll describe around wanting hydrology to be as natural as possible, storing water, using soil moisture, using supplementary local water supplies and irrigation to help mitigate outdoor and urban heat, space for vegetation, and quality of urban dwellings. There are then criteria which cover water performance, architectural and urban and outdoor thermal comfort. And then there's a set of indicators, both for water performance spanning hydrology, storage, supply and demand, and greening, and a set of architectural quality tracking both the quality of interior space, public space, and private outdoor space. We've got the case study examples if you'd like to see the application of that for existing development. So you can see here the pink area, which was an area of 130 hectares in Adelaide, at Salisbury in South Australia. And then business as usual, we could quantify which areas were likely to intensify, similar to the very early slide, and what that would mean for stormwater and urban heat. And then we could quantify the population for water sensitive infill development, with all cases growing in population from around 1,900 people to 5,000 people. And then we can compare the performance using the evaluation framework. So here are examples of the numbers, and 100% of the outer boundary of the circle is a good number, and 0% means a bad number. So business as usual, you can see its performance with regard to the numbers of households, the water storage capacity, the urban heat, architectural quality, hydrology, greening, water supply and demand is quite restricted, generally less than 50% within this particular framework. When we look at the water sensitive, red is the business as usual. The grey dashed line is the existing case, which has a large amount of outdoor private space, a strong performance indicator there. We then compare that with water sensitive conservative, which involves rainwater and stormwater harvesting, and water sensitive max, or the maximum water sensitive application. And we can use that to quantify how the performance of that development is improving. And then we can feed back that within architectural and design teams to look at what are the trade-offs that are occurring, and consequently, how do we optimize the design of that development across those multiple attributes. This has helped us identify a set of principles underpinning the evaluation of water. And in hydrology, we want designs to not cause further adverse impact on hydrological flows. We want to restore, ideally, the hydrology towards the natural case. In some cases, that restoration is possible. In many cases, that's not. And then well, not fully, but can certainly stop it deteriorating further. And there are a range of performance criteria we can use for that. We can look at water resources efficiency. So those designs incorporate water demand management and servicing technologies that reduce the reliance on water sourced from the external environment and optimize the internal or local harvesting of water. Water storage is critical, particularly so that design enables storage in local reservoirs and soil. That the dwelling and urban space are efficiently designed and equipped to improve the amenity and the usability. And the design, lastly, for urban heat enables passive mitigation of heat, which is becoming increasingly important. We've also found through that there are many links between water security and livability. And while this shows conceptually the links, we're now working to quantify many of those links in work by our PhD, Beata Sohachka. And so briefly, some of the key links between water supply, sanitation, drainage, affordability, river health and risk, has key linkages into essential services, green space, utility-owned green space, related water and natural bodies, etc. And so livability can be very strongly influenced by water. When we put all of this together, and particularly when we bring in the water energy nexus, we can start to ask, and these are very conceptual drawings of looking at both green skyscrapers and multiple or cascading water use and harvesting in different level buildings. We can start to ask across this space, what could we achieve if we use all the elements of rainwater harvesting, water reuse, green roofs, urban agriculture, hydropower, evaporative cooling, and thermal storage? And if we can start to think of our cities as a three-dimensional water harvesting machine, an energy efficiency machine, purpose-designed cooling system with water used to carry energy throughout while making it simultaneously a great place to live, then we can start to design better cities into the future. At the University of Queensland, together with other partners, we have put together a design challenge that brings together teams of planners, architects, water, energy and environmental engineers and others to collaborate across a week in a fast-paced, fun environment to achieve design solutions. I won't run into that in detail, but we're using that as almost an experiment to look at alternative designs, and the students build these fantastic designs and market them on the multiple attributes of water, energy, and livability. There are other tools available too, multiple other tools, particularly if you look at the CRC Water Sensitive Cities case study tool, which is available from the link shown on the screen. And I guess to conclude, I'd like to say that our cities are not currently well designed. Parts of them are, but certainly holistically they are not. They're hydrologically wasteful and damaging. Resolving this is a major challenge requiring multidisciplinary inputs from planners, architects, engineers, environmental scientists, social scientists and economists at least, and other disciplines. Water sensitive design, both land use and built elements, can enable intensification or more people living in cities, but also retain or improve hydrology and create more livable forms. Principles and key factors to guide both the site level and precinct level design are emerging. They include site context, climate, soil, slope and position, which is very important. And typologies or designs perform differently in different environments. Further consideration of technologies will help address larger flows of centralized water, because obviously if you're putting more people within cities, you can harvest water locally, but it also puts a further demand on the centralized water system to supply to that area. I'll briefly note some publications which are available at the end of the presentation, and also suggest papers and reports available from the website, the Advanced Water Management Centre website. And thank you very much for joining us. Thank you.
Hi, thanks for inviting me. I'm very pleased to participate at the water webinar series. My field of research is urban history, history of the city, history of urbanism, and landscape. And so my point of view of looking at water is probably a little bit different from the previous webinars. I would like to talk about how water is involved in the city and how water is involved in making a city. So I would like to start with a short overview of what I will talk about. All of these titles are very short topics, and I will talk about these topics through some images that I want to show, historical images of the city. And all of them talk in a different way of how water and the city are in a very close encounter. I will talk about the city built with water, about water as identity of the city, about water as a military strategy, about water as infrastructure for the city, water as the key for collective memory, for waterfront living, and for city marketing, and water and the leisure society. I will also talk about urban flood risk, and I will end with the water city, how to think and design with water. So first, the city built with water. This beautiful map is a map of Ghent in the 16th century. Water is here at the origin of the morphology of the city. Ghent is situated on the confluence of two rivers in a marshy lowland, and you can read the presence of water almost in the morphology of the city. And I would like to have a closer look to some of the details of this beautiful map, because it will show how water is involved in city life. For instance, this detail at the left hand, which is a very small detail of the map, shows different ways of drainage, but also sometimes irrigation of fields at the border of the city. In this detail, you see how water is like another barrier of defense and protection of the city close to the city wall. This detail shows how water is flowing under bridges, and these bridges or under tunnels, and these bridges can also be gates or fortified gates. And so the inhabitants are dealing with water to build their city upon the water. Another small detail in the map is showing how streets are running down from the hill towards the water and giving access to the water for domestic use. This is, of course, a very important matter, that people have access even for drinking water or other types of use of the water of the river. There is a harbor in Ghent. You can see quite big ships here coming from the region, out of the region, in the heart of the city. But you also have very small ships and boats that are used for very local urban transports and unloading and loading at the steps, as you can see here, of one of the streets in Ghent. And the river is also used for washing laundry, bleaching laundry in the meadows close to the river. So the river has also another type here, again, of domestic use. And the last detail here is how two people are fishing in the river. So the river also gives not only drinking water, but also food for the people living there. Now, let's have a look on how water also offers identity to the city. This is a map of the region of, you see the city of Ghent here. Here you have Antwerp, Brussels. This is the North Sea and the Channel. London is over here and Paris is over here. Just to situate the city of Antwerp, which is a large harbor and an international port today, but which is not close to the sea. It's inside the land, about 80 kilometers. I think it's good to know this. But Antwerp has always been a harbor. It's at the lower lee side of the river, in the meander of the river. And in this beautiful engraving, you can see how Ghent is represented from his most important side, which is the side at the river and at the water, where activities of the harbor are happening. And you can see many ships here. And you can also see, if you look close, there are gates over here in the city wall that give access to small canals that run inside the city. So smaller boats can go inside, and lots of the activities of the harbor are inside the city of Antwerp. So the engraving, the artist here wants to show Antwerp from its best side. Same in this picture here. The water side is again here represented as the waterfront side of Antwerp, is the most important side of Antwerp. It's a beautiful picture with a very special light. And it's actually drawn from what they call the left bank. It's the other bank at the other side of the river, looking over the river towards Antwerp. What you see here is it's a kind of a division in strips of the painting with 4 or 5 horizontal strips. You have a first strip here with the agricultural land. We are standing here actually in Flanders. The river is the border of Flanders with the other region, which is Brabant. Antwerp was in that time still part of Brabant. So not only the river is a place of the harbor activities, but also an administrative border between two important regions. So you have a horizontal strip of agricultural land, a horizontal strip of the river, then you have a strip of the city of Antwerp, and then you have a strip with a huge cloudy sky. And at the left side here, you see some people standing there. These are like us looking to this spectacle of Antwerp. It's a painting of the 17th century by Jean Bonnecroix. And in this image, even the waterfront of Antwerp is even represented in its most glorious way, and with all the important ships on the river, with these huge fortification walls and some new extensions also at the left side and at the right side, and then all the monuments inside the city with the cathedral in the center. But you can see how this is what they call the portrait of the city of Antwerp. It's a portrait of a city, it's an urban portrait, how this portrait wants to emphasize the presence of the water and the presence of the river Scheldt, which is the birthplace of the city of Antwerp. Of course, you have other kinds of representation, like this map here, which is a little bit, it's when you compare with the portrait of Antwerp that we have seen before, this is like upside down because the harbor activities are like situated at the backside of Antwerp with the river. And the most important part of Antwerp here are the fortifications and the citadel. It's more an administrative map where the buildings of Antwerp, with all the list of the buildings down there, with the shills of the region, the city of Antwerp. This is more a map which want to be representative for the government and the administration of Antwerp. But still you can see the presence of water not only in the river, but also along the fortification. Oh, I'm sorry. Along the fortification of the city of Antwerp, around the citadel. And if you look close, you can see here the little canals coming inside the city where the harbor activities are situated. This is a new extension of Antwerp with new harbor activities running inside the city. So this kind of representation from the other side, this is actually seen from the east towards Antwerp. Again, we are here like at the backside of the city, and the water of the river is almost not visible anymore. You can see at the horizon a little bit of the brilliance of the river Scheldt, but the water disappeared here in favor of showing the fields, the agricultural activities, but also the gentle people walking over here, because the region of Antwerp was also a region of residences, leisure, and habitations of wealthy people. So let's now go and have a look at another type of use of water and functions that water has in the city, which is the military use and the military strategy. This is, of course, a very important matter, especially in those times, 17th and 16th century, when we talk about Antwerp. This is an amazing picture which is made by an inhabitant, someone who was residing in Antwerp, Michael Eitzinger. And he was like the witness of this very important event in the 16th century, which is the siege of Antwerp. So what we see here in this drawing is the city of Antwerp at the horizon over here. It's quite small here, because what happens actually is everything what you see in the foreground is the siege of Antwerp. And the river Scheldt is what you see here amid the two dikes. But what happened is that these dikes have been broken by purpose so that the water can flow over the fields and acres and inside the polders, also at this side, so that boats from the Netherlands could come to Antwerp to help the Antwerp ships to battle against the Spanish attacker. The Spanish wanted to close off Antwerp, to starve the people of Antwerp with this barrier over here, this dam over here. There's another dam over here. And so what you actually see in this picture is how water takes over the territory and becomes the battlefield for ships. The whole surface that you can see here is it's several hundreds of square kilometer actually. The ships are, of course, out of scale, and this makes of this drawing something very particular. This is the same battlefield, but it's a representation 100 years later by Jan Luyken. Again, you see the city of Antwerp over here at the left side. This is the River Scheldt, and then all the inundated areas in the polders around the river where the battle with the ships can take place. Of course, this was not, the peasants and with the cattle living there were not very happy with these military activities, but that's another story. Now, using water for military strategy was not so exceptional. I show here at the left side here a map of, this is a large part of the Netherlands, what is called the New Holland waterline. It was a defense strategy for the Netherlands at the east side, because Germany was at the east side and they wanted to defend against Germany in those centuries. And the strategy was to have a system to inundate large parts of the Netherlands to stop eventual attacks from the east. And so this system was made out of locks and sluices and canals and rivers that could inundate large parts here. And you can see some of the machines and sluices and fortifications in the margin of this beautiful map. I show another example of water as a military strategy. This is in the First World War. The black line in the center here is the front line between the German army and the Allied armies here. At the border of Belgium, this is the border of Belgium, it's the last strip of Belgium which was still under Belgian control. But with positions of different armies, you have the Belgian army over here, the British army over here, and then France starts over here. And then it runs down until Switzerland. But what is particular, I'm sorry, again, is the inundation over here. It's again the same tactique to stop the army by inundating land. And this was a peasant who had this idea, and he opened the locks and the sluices in Newport to let the North Sea water coming in and inundate the polders. The picture that you see here is just right after the First World War, with the battlefields still muddy and the water is going away. And it's a picture taken by Jean Massard, a botanist who was extremely interested in this phenomenon of this salted water taking over the polders, and what he was interested in, what types of plants would start to grow there after the First World War, after this strategic inundation. So you can see how this war scene becomes another type of scientific field, actually, after the war. Let's have now still another look at water and its relationship to the city. We are again in Antwerp. It's a map that shows the whole waterfront of Antwerp. This is the River Scheldt. This is the city of Antwerp. This is a new extension with new docks over here, and another extension. It's under Napoleon with new docks at the north side, and this is the south side. Now, if you look close, you see some lines over here, and I will show a detail. This red line here and this dotted line over here are the new alignments of what the city of Antwerp wanted to construct, namely a new case in front of the city, because the old system of canals going inside the city was became old-fashioned and not functional anymore, and only smaller ships could enter. So they wanted to master the water of the river so that big ships could come against the quay alongside the city of Antwerp. So this was again the same alignment of the new case. You can see what a huge part of Antwerp had to be demolished to build these quays in front of the city. And so you can see how the harbor activities and how the water as a kind of infrastructure was taking over over the water as a kind of a natural flowing river. This is the old fabric and the old morphology of the city of Antwerp, and this is what came afterwards. So you can see that these new quays over here with open warehouses and a completely linear, very rational open surface in front of the city over here has taken over lots of this urban fabric that you can still see over here. The canals and basins going perpendicularly in the city is what you can see over here with this type of ships. And they are then replaced by the new quays and this type of industrial activities and huge ships alongside the quays. Now, let's go and have a look in more recent times now, what happens with water and the city. This is a Google map of the city of Antwerp. The city of Antwerp is situated over here. You can see, and these are the quays that were built that I just showed before. You can see how huge this harbor of Antwerp became in the 20th century, especially after the Second World War. So the harbor, which was situated in front of the quays and a little bit in the north and in the south, became a kind of an international port, the port of Antwerp, which has nothing to do anymore with the city of inhabitants of Antwerp. So in a certain way, it became a kind of an abstract zone for the people living in the city, and the city itself lost the harbor that was since centuries situated in front of the city. Now, that's also the reason why some of the inhabitants at the end of the 20th century, 20, 30 years ago, wanted to renew the river and the relationship between the city and the river. So they started an international competition for urban design where three parts of the city were the topic of the urban design competition. The older harbor of the time of Napoleon, the quays in front of the river, and the third zone that we are less interested in. So this competition was very international and was won by Manuel de Sola Morales from Barcelona. And he proposed for the north part of what they call the islet some new beginning of an urban neighborhood. Before it was a complete harbor neighborhood, but he wanted the city to penetrate in this neighborhood and start taking it over. So that's why he foresees a kind of a cultural activity here, and then some towers, living towers, apartment towers alongside the basin over here, and some new types of housing over here. That was very successful, and in the last 30 years, this zone of the harbor of the Napoleon time is now taken over by what you can see here, new apartment buildings, a new cultural museum over here, huge museum over here, a new park, new housing and renewal and renovations in this part over here. Harbor for leisure ships and yachts over here. So the city of Antwerp, which is situated over here, is now discovering in the last 20 years this part of the city that was unknown. And it also changed the representation and the image of the water itself, because where the water was a kind of infrastructure for the harbor, it became now a kind of an attraction and a kind of attractor for leisure activities, for walking, but also just for a kind of an aesthetical experience. And so the water now has a completely different kind of image. I show you this project also from the city and the river competition by the Japanese Toyo Ito, who wanted to, this was an ancient dock that he wanted to dig out again because it was filled up and there is a parking lot on top of it. He wanted to dig it out again and put a new park inside it, but this was not so much with I mean, the inhabitants didn't like this so much, and the image of the water that he wanted to recreate in a kind of a metaphorical way was not admitted by the inhabitants. I go to Ghent now. This is an image of the city of Ghent, where the same type of waterfront development as from the end of the 20th century, 1990s, you could find all over the world. Actually, think about New York, think of Rotterdam, Amsterdam, London with Canary Wharf, and all types of harbor cities, Hamburg, for instance, who have huge new neighborhoods developed alongside the former industrial harbors. This is in Ghent. This is a plan made by the famous Dutch architect Koolhaas and OMA. And this is now under development. So lots of new apartment buildings are being built in Ghent also for this type of waterfront development that is kind of a new generation of water relationship for many cities all over the world. In Antwerp, it is this may be a very good example of how water and the presence of water, the proximity of water, is also very positive for the development of this kind of city marketing buildings. This is a building made by Zaha Hadid a couple of years ago in finished in 2018. It's the Port Administration House, which is built on top of a former fire brigade building for the Port of Antwerp. So the administration wanted a new building, which has now become kind of a symbol for the harbor of Antwerp and for the whole city of Antwerp, as it represents not only kind of the body of a ship and also kind of a cloudy sky, which is reflected in the mirroring glass of the building, but it also reflects the diamonds industry, the industry of diamonds for Antwerp, as it is a very, very famous industry of Antwerp. So you see how, and the water and other elements of Antwerp are used in this kind of city marketing building to promote and the harbor and the diamonds and tourism for the city. A short chapter here about leisure. This beach was a river beach next to the river in Antwerp, the so-called Cintana Beach. And this is somewhere in the 30s. And I show this image. It was a very popular place, and it still exists with many people going there. But maybe also overcrowded, and that's also one of the reasons why Antwerp is developing new parks like this park, built on top of a former railway yard. It's designed by the Italian Bernardo Secchi and Paola Vigano. And it's not only a popular park, but there's also a kind of a beach that they have foreseen in this park, and you can see how popular this is. And again, this is the proximity of water and this image of kind of a leisurely place that water suggests by its presence. Some words now of very serious matter also, which is the urban flood risk. This diagram here shows the high tide of the river Scheldt in Antwerp, and it gained over a century more than a meter in average level, and half tide also gained 20 centimeter in a century of time. Because Antwerp is a tidal river, so every day the Scheldt goes up and down for 4 to 5 to 6 meters. So that's a lot of movement, and there were prospects that the water would. The level of the water would raise for 2 meters in the next century. So Antwerp was then urgently thinking about protecting itself against the risk of flooding. And so that's why during the city and the river competition in the 90s, a lot of attention of the designers was going to how to resolve the protection of the city on the case and still keep it as an interesting place. Now that the industrial activities are gone, this place became a kind of a beautiful, empty, large zone in front of the city. So the designers wanted to keep this kind of place and offer this to the inhabitants. And so you can see here in the prize-winning project of Beth Gali, some of the solutions that she invented for raising the level of the protection and at once also keeping the interest of the case. Now this was, Beth Gali didn't get actually the implementation of her project, but it was 20 years later taken over by another design group, WIT, who continued more or less the same type of approach. And so they wanted to keep this zone in front of the city and give the inhabitants kind of a free space to walk. Now the problem with when you raise the level of the of the case, or when you put a dike on top of it, the problem is that you block off the view on the river for the inhabitants of the city, as you can see in this image here. So the solution was to put the dike in the middle of the case so that you have a kind of a walk and car zone at the side of the river. And that's what you see at this side over here. And at the side of the river, you still have a kind of an open zone with a beautiful open air walking space. Underneath, they foresee a parking lot. And this is more or less the effect of what they were opting for. It's a beautiful walking space on top of the dike that slopes down smoothly towards the river. And so there is a huge proximity to the water for this open zone close to the river. This is a contemporary picture, very recent, of that zone, and you can see how beautiful the space is and how smooth people can walk from the dike towards the water. So the city of Antwerp still has a very good protection now for the future, and at the same time a new beautiful walking zone. And I want to finish very shortly with some words about now a new plan for Antwerp, because Antwerp is a kind of a water city, like many cities in that region, like Ghent and Bruges, and also in the Netherlands, of course. So Antwerp started with a plan for the water city, and they foresee three types of water, actually. One type is the artificial water city, and they, with this term, they refer to all the artificial mechanisms and machineries that have been made to master the water in a big city as Antwerp, all kinds of pumps and sewers and pipes and sluices and all kinds of things. The second plan will involve the hidden water city. This is the water, this is more like the heritage kind of water of old canals or underground canals, even reservoirs that can be involved in a new water approach for the city of Antwerp. And the third plan is the natural water city and all the different rivers, the huge zone of basins and docks of the port of Antwerp, the river, and also all the different water flows which are in the region of Antwerp, are all linked in a certain way and need to be mastered for the coming decennia because of the flooding risk and the seawater level raising with, as I said already, probably 2 meters in 100 years. So this is in some images and a few words, different approaches of the city and its relationship to the water. I thank you very much, and I will welcome all kinds of questions if there are questions. Thank you.